Right. So, a particle is projected from point O on horizontal ground and angle A to the horizontal. The initial speed is root g meters per second. It hits a small target whose position factor relative to O is a half I plus a quarter j meters. Find two values of A to the nearest degree. Alright? Draw yourself a nice picture. Right? And what we're going to say is this. There's a target here, and its location is 0.5 and 0.25. Are we cool with that? Sx has to equal 0.5. At the same time, Sy equals 0.25. That's the deal. The two of these have the same time. Everybody agree with that? Two ways you can go at it. You can throw it nice and narrow, like so, and hit it on the way up or even on the way down, I don't know. Or the second one is you can go all the way up a really high pitch, and what happens? You smash it on the way down. That's why there's two angles. You can hit that target two different ways. Are we cool with that? Now, we're going to do what we always do. We're going to put in our four equations. Okay? You're just going to organize them. So, dx equals u cos alpha. Huh? Oh, sorry. Yeah, my bad. U is root g. So anywhere you see a u, you know, place it with root g. Thanks, Phelan. Root g. Root g. Root g. Alright. Dy equals root g sin alpha. Or sin A minus gt. Sx equals root g t outside the square roots cos alpha, cos A, and finally sy root g t sine alpha minus a half g t squared. Generally speaking, which one's easier, sx or sy? Sx is considerably easier than sy, usually. Okay? Yes?
Use variables for like primacy and
No need. They can interact with each other and divide into each other or cancel each other on occasion. There's no need. Root g and g will.
the u is down from root g, that's different from gravity.
Oh no, it means the square root of gravity. They wouldn't touch it otherwise. But that's a good idea. Yeah, if they were to do something like that, you would change variable for something else. But no, it very much means square root of gravity. Okay. Now, I'm in a game show or something. Now, here's what we're gonna do. I'm not gonna do sy equals 0.25 and use the minus b formula to solve the most ridiculous two t values ever. Does everybody get that? That's not going to happen. What I am going to do is I'm going to use the linear sx value, and I'm going to put that equal to 0.5. Alright? Then I'm going to divide by root g cos alpha. So I'm going to get time of flight, or time it takes to hit that, not the time of flight, equals 0.5 over root g cos A, or for those of you purists who like the fractions, that there. Okay? 0.5 is a half. Now, what am I going to do with this t value that I just learned? Huh? Yeah, sub it into the sy. So I'm going to get sy equals root g, and then times t, which is 1 over 2 root g cos A, and then minus a half g. Now I gotta do t squared. So this thing here, I'm gonna square it. And when I square it, I get 1 over 4g cos squared alpha. Did I forget a sine alpha here? I did. Okay. Now, it's a lot of cancelling. So it's going to be a half sine alpha over cos alpha, or sine A over cos A. Then it's going to be the g's cancel. So it's going to be 1/8 divided by 1 over cos squared A. Now, we have and this all equals, we forgot what it equals, 0.25. Okay, any suggestions? 2 target areas, here they are, target area 1, target area 2. What do I change them with? Huh? Yeah, so this is a half tan alpha, and this is going to be minus 1/8, and then what do I change that with? Equals 0.25, which is actually a quarter. Alright, common denominator, anybody? An 8, isn't it? So, change this one to 4 tan alpha. Leave this the same and multiply it out. This needs to be multiplied top and bottom by 2. So you would have got 2 8s. So just 2 on top. You have a quadratic equation, so minus tan squared alpha minus 4 tan alpha minus 3. Multiply both sides by negative. If we kill that, then I'm going to get tan A plus 1, tan A plus 3. Oh, that's interesting. Give me a second. I'm thinking I'm getting negative tan values here, which means an angle bigger than 90. So I'm suspecting an error. Okay, did you find my error?
Yeah.
What I've learned is that in the past, you know about this ASTC business I showed you before, don't you? Maybe you took it down one day. Now, all means from 0 to 90. When you're talking about showing angles, it's always 0 to 90. Does everybody agree with that? When you're showing your angles, it's always 0 to 90. Which means that tan, sine, and cos are all positive. I was about to get two negative tans, and I knew that was wrong straight away. So what we did was we went up a couple of levels here, and we realized I had plus 4 tan A, and I made a mistake here. It should have been still plus 4 tan A, and then when I multiplied across by minus, it's minus 4 tan A, and then you fix it up like so, and that's a minus, and that's a minus. And that's how you knew the mistake was coming. Okay? And then you get tan A equals 1, perfect, positive, and tan A equals 3. It's a short angle pitch and a high angle pitch as predicted. When you tan inverse, you'll get A equals 45 degrees, and tan inverse 3, 71.56 degrees. And you're done. Alright guys, if you guys try question 3 on your own, and I'll come in behind you in a minute. Right. So question 3 is very similar to the one we just did. You have a u value of 4 by root 2g. So you're going to get px equals 4 root 2g cos A. Py equals 4 root 2g. The g is inside the square root sign. sine A minus GT. And Sx equals 4 root 2G T times A. Sy equals 4 root 2GT sine A half squared. Now, it's the top of a narrow wall, so at the same time where Sx equals 8, Sy has to equal 14. So you're better off putting Sx equal to 8 and finding the t value there. This means the t value will be 8 over 4 root 2g cos A, and 8 over 4 is 2. Again, 2 over root 2g cos alpha. Substitute that into the y equation. And when you substitute that into the y equation, so 2 root 2g A, square that out, you should get 4 over 2g cos squared A, all equals 14. Stuff will cancel. 2 times 4 is 8. Sine alpha over cos alpha will be tan alpha. 8 tan alpha. No, the 4 will cancel to 2, so you're just going to have 1 over cos squared A, 14. 1 over cos squared A changes to become 1 minus tan squared A. Yeah. Alpha plus 8 tan alpha minus 15. Yeah. No. Minus 1. Anybody get that? Oh, it's 1 plus tan squared A. Yeah, that makes sense. Because then when you multiply across, they become nice numbers. Yeah. Yeah, that's a lot nicer. So tan alpha equals so 2 relatively high throws, aren't they? Either way, two high throws. So tan alpha equals 3 and tan alpha equals 5. If you want ridiculous accuracy, don't use decimals and don't round off your angle. So if you want to be ridiculously accurate, which we do, see the way that's 5 and 1? That means that'll be root 26. And what do we need for the time of flight? We need to know what cos alpha is for the time of flight. So this would assume that one value of cos A would be 1 over root 26. No rounding off required. And what about the other one? 3 and 1 would make that root 10. So the cos alpha value would be 1 over root 10. Your two times would be, oh sorry, time of flights. Sorry, I'm wrong. Excuse me. We don't actually have the time of flight yet. How'd you get the time of flight? I remember how you get the time of flight. It's where the ball hits the ground. So what you do? Go back up to SY. Don't need anything else here. And what do I do with SY? Put SY equal to 0. There is there. In seconds. Put equal to 0. And then you're going to get a half gt squared equals 4 root 2 gt sine alpha. The t's will cancel. The g's won't cancel because they're in the square root, aren't they? So just give me, yeah. Oh, sorry. I'm stupid me. If it hits the wall, that's the end of the journey, isn't it? So that's the time of flight. Sometimes it narrowly misses the wall, and then there's a time of flight. So lads, I was right with my initial proposition, okay? So there's two types of questions. One where it barely misses the wall, and one where it hits the wall. When it hits the wall, the time of flight is in fact, where did we say got the time of flight again? What was it? There it is there. This here is your time of flight. Have we got that? So what do I do with that value then? I have two values of cos A. So the two values are 2 over root 2 g. Cos A for one of them was 1 over root 26. And for the other one, it was 1 over root 10. Can everybody put them into the calculator and put g as 9.8? And you should be able to get me an answer for both of them. Does anybody have the answer for both of them? Let me know. Alright. I'll show you how to do one of them maybe. Get your calculator out, you do 2. On the bottom you do the square root of 19.6 because that's 2g. And then that's multiplied by 1 divided by root 26. And anybody get a time of flight of 2.3 seconds? And the other one will be 1.4 and 2.3 seconds respectively. Alright. Suppose you guys have a go at the following questions for next day: 5, 7, 9, 11, 13 and 14. The only two that are on the YouTube channel are 13 and 14, okay? So if you just Google Unicram, just Google Unicram 3C and those two will pop up on the search engine, okay? I think we're good to go.